Hello, 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 hello. Am I audible? Am I visible? Welcome to our class. Welcome to the YouTube channel on Academy CSIR. Is everything clear? Audio as well as video. So today in this class, we are going to discuss a very important topic of quantum mechanics section, hydrogen atom problem. Now, you know that in almost every consecutive year, you get a question from hydrogen atom problem. So it is very necessary to know about this topic in detail. And today we are going to discuss that. So audio and video, everything is clear, guys. And wish you all a very good morning. So आज हम लोग पढ़ने वाले हैं hydrogen atom. So most of you are knowing this hydrogen atom from the very basic level, like from class 5 to from class 6 as well. You are introduced to with hydrogen atom, and until your M.Sc also, you will keep on reading this particular hydrogen atom problem. So without any further delay, let's just start our class. So guys, my name is Sahin Sorifi and I'm a class educator on Unacademy. And this is our referral code, Sahinlive. So you can take an Unacademy class subscription using this. And an important announcement that Unacademy Accelerator is going to start. It will be conducted on February 28th, Sunday from 12 p.m. to 1:15 p.m. So this test will be having 30 questions, and if you appear in this test and if you can bring a rank between 1 and 2, you will get 100% scholarship on subscription. Vijit, good morning. And rank 3 to 10 will get 75% scholarship on a subscription, and rank 11 to 35 50%, and 36 to 150 25% scholarship they will get. And the condition is you have to attend the test live to be eligible for it. So practice भी हो जाएगा और अगर अच्छा रैंक आ गया तो आपको scholarship भी मिल जाएगा. So it's a very good opportunity you can think of. And these are the courses currently ongoing. This batch course is going on by 3 educators, me, Anjali ma'am, and Om sir. And I'm also taking a complete course on thermal and statistical physics, so you can attend this course. And a detailed course on electromagnetic theory has also been started. So if you think you should cover the whole electromagnetic theory, then you can join this course. This course will be very helpful. And another batch course is going to has started already, February 2020, February 22. So you can just join this batch courses if you want. Use our referral code physics or Sahinlive to get 10% off on the subscription. And this is our class schedule. We take classes on every Thursday, Friday, and Saturday, and these are the free classes. Okay, the respective platforms are shown, and Unacademy Plus class we take it on every Monday to Saturday, 9 to 10:30 on Unacademy Plus. Okay, so without any further delay, let's just start our class, the hydrogen atom. So we'll give you a brief idea about the hydrogen atom. Then we'll go for some quantum mechanical approach. The hydrogen. Okay, what is the component of an hydrogen atom? So you know that in case of hydrogen atom, if you consider classically, then it has some proton of charge plus E, okay, and one electron is there which is moving along this. Okay, let's say this is electron, and the separation between the proton and electron, let's say this is given by R. Okay, so we can consider just write a few lines to make it understand more clearly the hydrogen atom. So in as compared to the mass of an electron, the mass of a proton is considered to be heavy, infinite in mass. So the hydrogen atom consists of a heavy, okay, because the mass of proton is much greater than the electron. So as compared to the mass of an electron, it is heavy and motionless. Okay, motionless proton. And one proton is there, so therefore the charge will be plus E, of charge plus E, okay, together with a much lighter electron. Basically, I have shown you in this way that electron is a single entity, but it's an electron cloud. Okay, the charge is here minus E. Okay, that circles around it. Okay, now if it is circling around it, there must be acting some force between them. Okay, so the force means held in orbit by the mutual attraction. Mutual attraction between whose? Mutual attraction of opposite charges. Mutual attraction opposite charges. So we are going to equalize these two forces. Okay, the forces due to the attraction and the forces coming because of the revolution. Okay, so we can write the potential because of the interaction between the proton and the electron. The interaction potential is equals to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, q1 q2 by r. Here q1 is E, q2 is minus E, so minus E square by r. So this is the potential followed in case of hydrogen atom. So you can see this is a central potential. This is a potential which is only depending on r. R means the position of the electron from the proton. So this is central force. Now, if you know the potential, we can easily fit this or utilize this in Schrodinger equation. Okay. Now, Schrodinger equation. We are going to utilize Schrodinger equation in 3D. So, do you know the form of Schrodinger equation in 3D? Del square psi. Good morning, Ashutosh. By del x square plus del square psi by del y square. We are just writing all the components. Del square psi by del z square plus twice m by h cut square E minus v into psi. This is equals to 0. So this is the Schrodinger equation form in 3 dimension. Now we are going to put this value of v of r here in this Schrodinger equation. Okay. Now look, this Schrodinger equation in 3 dimension can be solved using separation of variable technique. So you will get from here you will get some radial part and you will get some angular part. So the solution of this Schrodinger equation in 3D will consist of two parts. One is radial part corresponding to r and the angular part corresponding to theta and phi. So these two parts will be there in the solution. I think you know about this. So we are just trying to write the radial part. Okay, so solution of radial part of hydrogen atom. Radial part for hydrogen atom. What will be the solution for the radial part? The solution for the radial part can be written in terms of we are taking up spherical polar coordinate. Okay, so it will be 1 by r square del r into r square del psi upon del r. We are basically expressing this 3-dimensional Schrodinger equation which is in Cartesian coordinate system. Now we are going to transform it into spherical polar coordinate. So 1 by r square del r square del psi del r plus 1 by r square sin theta del theta sin theta del psi del theta plus 1 by r square sin square theta del square psi by del phi square plus twice m by h cut square E minus v into psi. This is equals to 0. So we have expressed the Cartesian Schrodinger equation, 3D Schrodinger equation into spherical 3D Schrodinger equation. Okay. Now what we're gonna do? We are going to multiply it with r square sin square theta. So multiply, if this is equation 1, multiply both sides of equation 1, both sides of equation 1 by r square sin square theta. Okay. Hello Abhishek. So at any point of time, if you have any question or if you face any difficulty in understanding anything, you can just ask me. I will try to help you out. So if you multiply with r square sin square theta on both sides, this first term will become sin square theta del r square del psi upon del r, plus this will be 1 sin theta, okay, sin theta del theta sin theta del psi del theta, plus the 1 by r square sin square theta, this will cancelled, so this will be cancelled, del square psi by del phi square, plus twice m by h cut square was there, and we have multiplied with r square sin square theta. So this will become r square sin square theta into e minus v. V equals to, you see, minus 1 by 4 pi epsilon naught e square by r. So we are just taking that e square by 4 pi epsilon naught r, okay, and plus e into psi. This is equals to 0. Okay. So this is the Schrodinger equation in 3 dimension. Now this is our ultimate equation and we need to solve it. How can we solve it? We solve it using the separation of variable techniques. Separation of variable technique. Okay. So we consider that the solution is composed of 3 parts. Psi, r, theta, phi. It is composed of 3 parts. One is the radial part, r of r, and one is the theta part, another one is the phi part. Okay, so we have written the whole solution by separating the variables, r variable, theta variable, and phi variable. And if you put this value of psi, this trial solution, in this particular differential equation, then you will get 3 parts. One part corresponding to the radial part, another part corresponding to the theta part, another part corresponding to the phi part. Okay, by applying separation of variable technique, by assuming this, we'll get 3 differential equations. We'll get the differential equations. So we are going to write the differential equations for 3 parts. Okay, you'll get 3 separate differential equations if you assume this. So what are the separate equations? So for phi, okay, for phi we'll get one equation. For theta we'll get another equation. Okay, for theta you will get another equation. So solution of this phi and theta will consist of the angular part. We'll make the angular part and the radial part for r. Okay, so firstly let's consider for phi. For phi, the differential equation will be d square phi by d phi square plus ml square phi. This is equals to 0. Okay, let's say this is equation number 2. The equation corresponding to theta will be 1 upon sin theta del theta sin theta del theta d theta upon d theta plus L into L plus 1 minus ml square divided by sin theta into theta. This is equals to 0. This can be achieved by plugging this value in this equation, and you will get some separated equations for r, theta, and phi. Okay, and what will be the r? Equation 1 by r square d dr, r square dr upon dr plus twice m by h cut square e square by 4 pi epsilon naught r plus e minus L into L plus 1 divided by r square into r. This is equals to 0. These many equations will have by plugging the separation of variable techniques in this. Now, if you find out the solution of this phi portion, the solution of the phi is given by this. Okay, the detailed solution is not required for your exam purpose, but the solutions are very important. 1 by root 2 pi e to the power I ml into phi. Okay, where ml runs from 0 plus minus 1 plus minus 2 plus minus 3 dot dot dot. So this is the solution corresponding to the phi part. Okay, now similarly we will get solutions corresponding to the theta part. 1 by sine theta del theta of this. So what will be the solution corresponding to the theta part? Okay, so we are going to write the solutions corresponding to the theta part. Okay, solution for theta part. So theta will be equals to a PLM cos theta. Okay, this PLM is the associated Legendre function. Associated Legendre function. We have read it in special function portion. This is known as associated Legendre function. Okay, a into PLM cos theta. Where this PLM value, okay, you don't need to remember this, but for the sake of completeness, I am giving you the value. PLM equals to 1 minus x square modulus m by 2 d dx to the power m PL of x. Okay, what is PLX? PL of x is the Lth order Legendre polynomial. Lth Legendre polynomial, which we have already read in case of Legendre polynomial. And how it is defined? It is defined by Rodriguez formula, PL of x 1 by 2 to the power L into L factorial d dx all to the power L x square minus 1 all to the power L. Okay, you know the first few values of this Legendre polynomial. Okay, now you know that p0 of x is equals to 1, p1 of x equals to x, p2 of x equals to half into 3x square minus 1. So you see the angular portion is given by this. So let me just briefly summarize what we are doing. So in hydrogen atom we have a proton and we have an electron. Okay, so this proton and electron combination is giving rise to this potential. Now you are going to utilize, we are plugging this potential in three-dimensional Schrodinger equation. Now solving it in Cartesian coordinates is difficult. That is why we are taking up spherical polar coordinates. Since we have written the three-dimensional Schrodinger equation in three-dimensional spherical polar coordinates. Okay, and we have plugged in the value of V and we got this equation. Now how to solve this equation? We took up this approach of separation of variable technique, where we write the combined wave function or combined solution as thus multiplication of separate variable. One variable for r, another variable for theta, another variable for phi. Okay, so if you plug in this value in this, you will get three differential equations. One will give you corresponding to phi, another will for theta, another will for r. And by solving this, you will get the phi portion, theta portion, and r portion. And ultimately, the total solution will be, combined solution will be given by the multiplication of these three individual solutions. So for the first one, for phi, we have already calculated 1 by root 2 pi e to the power I ml phi. Okay, and for the theta part, this is the solution, a PLM theta cos theta. Okay. So if I say that what is the combined wave function due to the angular part means theta and phi part. So we can just write the combined angular solution. Combined angular part of the wave function is given by, so we have calculated for theta and phi, so we are just combining, is given by spherical harmonics. Okay, spherical harmonics. The concept of spherical harmonics is very important. Okay, and that is given by a combined wave function, which is combined function, not wave function, which is given by y l m theta phi. Okay, by combining this a p l m cos theta and this e to the power I m l phi, we are getting this y l m theta phi. Okay, y l m has some property. Just if you calculate y l minus m, it will be minus 1 to the power m y l m. And you see p l m of cos theta. What is the value of this particular thing? It will be equals to minus 1 to the power m sin theta to the power m dm by d cos theta to the power m into pl of cos theta. Okay, look, these things are little bit odd in hydrogen atom problem, although they are not, they generally don't come in your examination, but the question which come in your examination which requires this concept, if you do not understand these concepts, you will not be able to solve the problems. The problems comes generally very easy, but you need to have these concepts, clear concept, even if you do not remember, but the idea should be there. That is why I am giving you all of these things. I don't even remember these things, like the formula, these are not required, but here the idea is you need to understand how they are going. Okay, now I am trying to give you some of the harmonics, first few harmonics. Okay, the first few spherical harmonics. पहले के कुछ स्फेरिकल हार्मोनिक्स आपको याद रखना पड़ेगा, जैसे जो कॉमन है एकदम y00, दिस इज बेसिकली 1/4 पाई. Okay, then y10, because by choosing L equals to 1, this has been obtained by putting L equals to 0, M equals to 0. So these things are very common thing. This is being generated by L equals to 0, sorry, L equals to 1 and M equals to 0. Then this will give you root over 3 by 4 pi cos theta. Okay, then if we calculate y1, okay, plus minus 1, this will be giving you minus plus root over 3 by 8 pi sin theta e to the power plus minus I phi. Sometimes these are required. Okay, then y20, this will be equals to root over 5 by 16 pi into 3 cos square theta minus 1. So at least try to remember these two things, then that is sufficient. And many more things are there, I think. And remember this thing, YLM, it is comprising of L and M. If some M is there, then only exponential term will be there. Look here, M is not there, M is 0, so no exponential term. M is 0, so no exponential term. But here you see M is equals to plus minus 1, so e to the power term, exponential term will be there. Similarly, just for showing you that how it is working, you don't need to remember this, but see here y has some value, M has some value, so this will also have some exponential term, root over 15 by 8 pi sin theta cos theta e to the power plus minus I phi. So whenever you see this plus minus something will be there in the place of M, you will get some exponential term, because that term is coming from this portion e to the power I ml phi. So depending on the value of ml, you will put the value. Okay, so this will help you to solve problem. आगे बढ़े दोस्तों. The next thing which we are going to discuss is orthonormality relation. Orthonormality relation for spherical harmonics. Okay, so orthonormality relation in case of spherical harmonics is given by this expression y lm theta phi. This is the spherical harmonics. Okay, if you multiply with this y lm theta phi, y l prime m prime theta phi, मतलब kind of psi star psi into the volume into this element sin theta d theta d phi. Okay, and you are doing the integration for theta, it is 0 to pi. For phi, it is 0 to 2 pi. This should be equals to delta L L prime delta M M prime. Okay, this is the orthonormality relation for spherical harmonics. Y L theta phi are the spherical harmonics. L is called the azimuthal quantum number. This is known as azimuthal quantum number. M is called the magnetic quantum number. Now, what is this y lm theta phi? So, if you combiningly write y lm theta phi, then it is given in this way: y lm theta phi. Look, the expression is a little bit complicated, but you can just consider it epsilon root over twice L plus 1 divided by 4 pi into L minus m factorial divided by L plus m factorial, okay, into e to the power I m phi e l m. So you see here in this solution a was there. So this a is giving rise to the complicated expression, and other than that e to the power I m phi was there. So I m l phi was there. It was remaining as it is. PLM cos theta is remaining as it is. So e to the power I m phi PLM cos theta. This is coming from the theta part and phi part, and this constant, this is a normalization term which we are getting, where this epsilon is equals to minus 1 to the power m for m greater than 0, and it is plus 1 for m less equals to 0. Okay. So in this way, her spherical harmonics can be written. So main thing you need to remember that this part e to the power I m phi into PLM cos theta. This is solution corresponding to phi part. It is solution corresponding to theta part. Good morning, Mayank Tagi. So we have taken care of the theta part and phi part. Now it is the time to go for the radial part. Okay. So the next thing which we are going to discuss is the radial part, the radial equation. So currently what we are doing, we are just discussing the solution of hydrogen atom problem by using three-dimensional Schrodinger equation. Okay. Now if you consider some spherically symmetric potential, if you have some spherically symmetric potential, then theta and phi will be same for all of the potentials. Okay, so angular part of the solution is y of theta phi. Okay, this is same for all spherically symmetric potential. Okay, so the actual part of the potential, shape of the potential, is determined by this radial part, because v is a function of r only, and we got the radial portion as d dr of r square dr by dr minus twice m r square divided by h cut square v of r minus e into r l into l plus 1 into r. Okay. So we have generally got this one. We are taking now general potential V of r. Okay. Now to solve this radial part, what we are going to take? We are going to take u of r equals to small r into capital R of r. So we are assuming this. Okay. So from here you will get r equals to u by r. If r equals to u by r, then dr by dr, this will become by r square r into du by dr minus u. Okay, and you will get ddr of r square dr by dr means the first part. This will get r into d square u by dr square. Okay, therefore this equation will be transformed into, if you just put this value of ddr of r square dr from this using this, so r into d square u by dr square, and if you multiply with h cot square by twice m r square, then what will you get? You will end up getting this expression minus h cot square by 2m d square u upon dr square plus v plus h cot square by 2m L into L plus 1 by r square into u. This is equals to E into u. You will get an equation like this, minus h cot square by 2m, this plus this equals to u. Okay, so this we have transferred into some equation. This equation is known as the radial equation. This is known as the radial equation. Okay. So, okay, let me just write it again. So we can draw very good conclusion from it. We have this radial equation. If say minus h cot square by 2m d square u upon dr square plus v plus h cot square by 2m into L plus 1 divided by r square into u. This is equals to E into u. So isn't this equation quite familiar to you? We know this equation, minus h cot square by 2m d square psi by dr square plus v psi equals to E psi. So can't you draw a similarity between these two equations? So here a potential term should be there, but you see here in addition to the term v, we are having some extra term, h cot square by 2m into L plus 1 by r square. Okay, so okay, h minus h cot square by 2m d square psi by dx square, let's say one dimensional Schrodinger equation. So we are comparing it with one dimensional Schrodinger equation, and we see this v is giving you some v effective. This is equals to v plus h cot square by 2m into L plus 1 divided by r square. Okay, so this expression is containing this extra term. This extra term is known as the centrifugal term. Okay, so because of this centrifugal term, it tries to throw the particles away from it. Okay, if it has a centrifugal term, because of this centrifugal term, the particle will be thrown out. Okay, na? Away from the origin. This is responsible to throw the particle away from the origin. If we plot this V effective versus R, what will be the form of this curve? You have already read it many times. So this will be the form like this. It will go like this. This is the form of V effective. Okay. So this is all about the solution of Schrodinger equation. Now we have discussed these things in detail. So is there any question you can ask me from the solution of hydrogen atom? Now we are going to talk about different parameters of this, like energy eigenfunction, okay, energy eigenvalue, what is the Bohr radius, all of those things. And we'll solve some problem. So let's start with Bohr radius, Bohr formula, okay, which gives an expression of energy. So we'll go for Bohr formula. This is quite useful in solving problem. Now what we are going to do are very necessary for your examination. So Bohr, according to Bohr, the energy of hydrogen atom is given by minus m by 2 h cut square E square by 4 pi epsilon naught whole square into 1 by n square. So this is written like this, E1 by n square. Okay, so minus 13.6 by n square, where n run from 1, 2, 3. So you know this is minus 13.6 by n square. E1 equals to minus 13.6 electron volt. Next, we are going for Bohr radius. What is the Bohr radius? Okay, before we go to the Bohr radius, let me just tell you alpha, fine structure constant. Few things we need to know. So Bohr radius means the radius of the first orbit. So Bohr radius is given by A equals to 4 pi epsilon naught h cut square by m e square. And the value has been found out to be 0.529 into 10 to the power minus 10 meters. So 0.53 angstrom. Now this is the expression of energy of hydrogen atom. So for ground state, what will be the energy? For ground state. For ground state, we know n equals to 1. Then what will be the value of E1? E1 will be equals to minus m by 2h cut square E square by 4 pi epsilon naught whole square, and it has been found to be minus 13.6 electron volt. Okay, so if this is the energy of the ground state of hydrogen atom, then can you say what is the binding energy? Therefore, the binding energy of electron, binding energy will be plus. Energy of the orbit is minus 13.6. The binding energy will be plus 13.6. The binding energy of hydrogen. What is binding energy? Basically, if you have, let's say this is electron. So if you want to extract this electron outside, you need to apply some force. You need to apply some energy. So that amount of energy which is required to remove an electron from its orbit is known as the binding energy. So binding energy means the amount of energy you need to impart to the electron, okay, to ionize it, to ionize that. So if one electron goes up, if one electron is left, let's say this is A, it will become A positive. So it has become ionized now. This is some atom, but this is ion by removing the electron. So binding energy of hydrogen atom will be plus 13.6 electron volt. Okay. Now I think all of these things are understood to everyone. Let's quickly move forward to for some problem. ये वाला प्रॉब्लम करके दिखाओ. आ गया. हाँ. the energy level of the non-relativistic electron in a hydrogen atom. Okay, the energy level of the non-relativistic electron in a hydrogen atom that is in a Coulomb potential V of R is equals to minus 1 by R, and the energy is given by E NLM proportional to minus 1 by N square, where N is the principal quantum number and the wave function is given by psi NLM. L is the orbital angular momentum quantum number. M is the magnetic quantum number. Spin of the electron not considered. Which one of the following is the correct state? कौन सा वाला करेक्ट लग रहा है आपको? लास्ट वाला देखो, ई एन एल एम ऑप्शन सी शायद नहीं दिख रहा होगा. ई एन एल एम डज नॉट डिपेंड ऑन एल एंड एम एंड फॉर द Coulomb potential, and option 4 is there is a unique wave function psi NLM for each NLM, and option B is there are L into L plus 1 different wave functions psi NLM for each NLM, and option A is seen there are exactly 12 plus 1 different wave functions psi NLM for each NLM. कौन सा होगा आंसर इसका? You can let me know in the comment section your answers. कौन सा होना चाहिए आंसर इसका? देखो, we have En equals to minus 13.6 by N square. So you see, this is only depending on L, not on L or M, okay, for this Coulomb potential. So option C will be the correct option, isn't it? Got it now? As it is containing, the energy expression is containing only N with a factor, so it will depend only on N, but it will not depend on L and M from the Coulomb potential. Option C. Yes, Bibhan. So this problem came in CSIR-NET June 2011. Now, if you understand this problem, a similar type of problem came in the June 2016. So this question is very interesting. Suppose the Coulomb potential of the hydrogen atom is changed by adding an inverse square term such that the total potential becomes V of R equals to minus ZE square by R plus G by R square. So this term was already there previously, and this G by R square term has been added. So G is a constant. The energy eigenvalue E and Lm in the modified potential will be given by. अब क्या हो जाएगा? B. B नहीं होगा. देखो, ये थोड़ा सा conceptual question है. So how can we write the Hamiltonian if V is given to you like this? Okay, so here we are doing the solution. So V of R, this is the modified potential. It is given by minus ZE square by R plus G upon R square. Okay. So therefore the Hamiltonian of the hydrogen atom becomes, Hamilton क्या हो जाएगा? H will be equals to P square by 2m kinetic energy minus ZE square by R plus G by R square. So we can consider this was the initial term H naught, unperturbed part, and plus this is a kind of perturbation we have read it. Okay, and we have seen that from this unperturbed part H0 we got En0. This is as conventional minus 13.6 by N square electron volt. This one we get, but because of this perturbed term HP, we will get another correction, energy correction, En1. This is basically G into, look, okay, perturbation of 1 by R square, G is constant, so expectation, the first order correction is given by this. So this will have the value like this, 2 by n cube into 2l plus 1 a naught. So you do not need to remember the expression, but you just see it is containing both n and l. Okay, and the total energy eigenvalue is given by the parted portion plus the energy correction. And from this expression of En1, if see it is depending on n and l, so we can conclude that En depends on n and l, but there is no related term related to n, but not on m. Okay, so option A is the correct option for this question. Understood? समझ में आया? Because in the expression of energy eigenvalue, we are getting terms related to n and l. That is why it will depend upon n and l, but not on m. Okay, now we are going to discuss an interesting thing. So we have considered that the wave function psi n l m r theta phi. This is a solution of hydrogen atom. Okay, wave function of hydrogen atom. So it will have two components, r n l of r radial part and angular part is given by the spherical harmonics y l m theta phi. So you see the total wave function is composed of one is the radial part, another one is the angular part. Now if you choose n equals to 0, n equals to 0, okay, then we get the ground state psi 1 0 0. Okay, sorry, if you choose l equals to 0 and m equals to 0, okay, and n equals to 1, basically n का value 1 से शुरू होता है ना, psi 1 0 0, this will give you the ground state psi r theta phi. This is equals to r 1 0 of r y 0 0 theta phi. Okay, so this is giving you the ground state wave function, where this radial portion r10 of r, this is given by a0 by a e to the power minus r upon a. A0 is the Bohr radius. Now if you normalize it, then you will get 0 to infinity r10 mod square into r square dr. Okay, this will be a naught square by a square 0 to infinity e to the power minus 2r by a into r square dr. Okay, and this term equals to how much? This will be equals to a naught square into a by 4. Okay, this will be equals to 1 according to the normalization condition. And from here, what are you getting? A naught square by a by 4 equals to 1. Therefore, a naught equals to 2 by root over a. Okay, and so we are getting the normalization constant a naught equals to 2 by root over a, and this y0 0, we know about y0 0. Y0 0 equals to 1 upon root over 4 pi. So these two things we are getting. So we can write the ground state wave function as this. Knowing the ground state wave function is quite important. You have to remember this. So ground state wave function psi 1 0 0 r theta phi. This will be equals to 1 by root over pi a cube e to the power minus r by a. Okay. So sometimes in your question this formula is given, sometimes it is not given. So it is better you remember this is the ground state wave function of hydrogen atom. Psi 1 0 0 r theta phi equals to 1 by root over pi a cube e to the power minus r by a. A is the Bohr radius. ठीक है. Yes, probability density graph, we are going to do it in the next section. Yes, yes. KGF, just hold on a moment. So now we are going to define radial probability density. Radial probability density. Radial probability density is given by P of R dr. Many of the questions came from this one. This is given by R square R NL mod square into dr. Okay. So this is the radial probability density PR dr. R square RNL square dr. Probability density was this the normal density. So mod size square was there, but here you see R square is multiplied. Don't forget it. Okay, radial probability density R square will be multiplied. So we take the example of the ground state psi 1 0 0 r theta phi. This is, we know, 1 upon root over pi a cube e to the power minus r by a, and this is basically r10 into y00. Okay now, so r10, this is equals to 2 by a to the power 3 by 2 e to the power minus r by a. We have we have shown it here. 2 by root over a, and a is already there, so 1 plus half 3 by 2, that is a 2 by, this is equals to 2 by a to the power 3 by 2 e to the power minus r by a. That's what we have written here, 2 by a to the power 3 by 2 e to the power minus r by a. Therefore radial probability density will become radial probability density. It will become P of R dr. This is equals to r square into r10 whole square dr. This will be equals to 4 by a cube into r square e to the power minus 2r by a into dr. Okay. Now if you want to calculate the most probable distance, okay, so most probable distance will correspond to, let's say we are plotting the radial probability density versus r. The most probable density will be this point. Most probable density, if the curve is like this, most probable density means the maximum point. What is this point? This point will be a0. This will give you the bore radius. Okay, the most probable density is bore radius. Here we have utilized a, or this is also equal to a0. A and a0 is same here. Okay, so a equals to bore radius. We can also show you how we are getting the most probable distance from this probability distribution. So if you want to get the most probable distance, what you need to do, at this point you see this is a maxima, and maxima, what happens, dp upon dr, this should be equals to 0. Okay, so if you take the derivative of this thing and if you equate to 0, then you will get a equals to r equals to a naught, which is equals to the bore. So that is why this will be the representation. Okay. Now you see, depending on the value of n and l, you will get different radial probability density curve. Okay. So here in this figure, I have shown you the radial probability distribution curve. So Mr. KGF Prince, just look at these things. So these three curves are very important. Energy, ground state energy of hydrogen atom is always 0. The ground state atom of hydrogen atom always 0. KGF, what is, you are mistaken here. En equals to minus 13.6 by n square. N starts from 1, 2, 3. So ground state energy minus 13.6 electron volt, not 0. क्या बोल रहे हो, 0 नहीं होगा? देखो, For ground state na n equals to 1 na. This is the formula for ground state n equals to 1. We put n equals to 1, we got minus 13.6. जीरो कैसे हो सकता है? ये नेगेटिव होता है ना एनर्जी हाइड्रोजन एटम का, according to quantum mechanics. Actually this is according to quantum mechanics, no? We have zero means what a high, okay. So you see this is minus 13.6, this is the ground state, then we get the fast excitation, this is also negative, okay na. Then another energy state, then it becomes continuum, no? It is correspond to zero means what? Zero means huge energy. In case of hydrogen atom, it's very high excited state. In Stark effect, yes, that the energy correction is zero. It got confused little bit. तुमने मुझे भी confuse कर दिया. That is the perturbation, no? First order linear Stark effect जो होते हैं, that is zero. Okay. Just ping me on WhatsApp or somewhere. I will send you that portion. Okay, where you will get the exact idea of why it is zero. In Stark effect, that is the correction is zero. But energy of hydrogen atom is not zero. It's minus 13.6 ground state energy. And here in this figure, you can see the different wave function. This is RNL of R. So this is 3s, 3p, 3d, 2s, 2p, 1s. And this is radial probability density curve. R square RNL whole square. So you just save this photo. This will help you a lot. A lot of questions come from this. Yes, the D1 is saying correct thing. Energy shift may be zero because of the perturbation, but energy not equals to zero. Okay, so here you have a good concept. What is the meaning of energy to be zero? It's like, let's say this is a positive value, this is the electron in the n equals to 1 state. So the ground state, it is having energy E equals to minus 13.6. So if you want to make it zero, we have to apply 13.6 electron volt energy. If you add 13.6, then it will become zero. Okay, so it's just about to release from this orbital. चलो आगे बढ़ते हैं. ये वाला क्वेश्चन करके दिखाओ. The ground state of function for the hydrogen atom is given by psi100 this. देखो, in your question the wave function is given. As there is the Bohr radius, the plot of the radial probability density for the hydrogen atom in the ground state कैसा होगा? From the application of hydrogen, electron does not reside inside the nucleus. Yes. So in hydrogen atom, mass of nucleus taken as infinity. Mass of nucleus is taken as infinity because of the very negligible mass of an electron. Okay, this is coming from Rydberg constant. So Rydberg constant is defined for infinite mass and for finite mass. Infinite, the nucleus is considered to be infinitely heavy as compared to the mass of finite, very small and finite negligible mass of an electron. That is the idea of considering this nucleus as infinitely heavy. Okay. Option D will be the answer. Yes. So we have shown you that the expression you see, this is a Gaussian function kind of. So radial probability density will be like square of it. So P of R will be mod psi square R square. So this will be 1 by 4 pi n by a naught cube R square e to the power minus 2r by a naught. So this will corresponding to option D. Okay, ये वाला क्वेश्चन करो अभी. ये Which one of the following represents the 3p radial wave function of hydrogen atom? B. Okay. So we had a lot of questions to do, but okay, those who have not captured this, you can just take a screenshot of this. This will this has kind of all kind of this radial wave functions and all. And I would like to give you some problems as homework. So this problem came in CSIR-NET June 2014. An electron is in ground state of hydrogen atom. The probability that it is within the Bohr radius is approximately equal to. इसको कैसे करोगे? So take it as homework. Time is up. So what will you do? Probability that the electron is within the Bohr radius. The probability will be given by psi 0 star psi 0, okay, into d tau 4 pi r square dr. Now it is to be remaining within the Bohr radius. So the limit will be from 0 to a, 0 to Bohr radius. Okay, and you will see what you are getting from this. You will get 0.32. Okay, so this is the probability of the electron to remain inside it, 0.32. Okay, and then what will be the probability to remain outside? It will be 1 minus 0.32. Next question. Okay, यहाँ पे this came in December 2018. So you can see the pattern. This came in June 2014. This came in December 2018. So if you remember this result 0.32, we can usually predict the result like 0.66 or 0.68. Okay. So if you want to find the electron inside the Bohr radius, it will be 0.32. And the probability to find it outside is 0.68. So total 1 होता है. Total probability 1. Got it, KGF? 0.32 to find the electron inside the Bohr radius. And to find electron outside the Bohr radius is 0.68. The total probability will be 1. Okay. और कुछ था क्या? Okay, so एक और problem है, take it also as homework. This you take as homework. A lot of problems we had, but because of the limitation of time, we cannot solve it. We'll try to solve it at some other places. So normalized ground state function of hydrogen atom is given by this. So what will be the expectation value of 1 by r square? So also take it as homework. It is practical value or this is theoretical value. This probability, no? This is theoretical value. Probability कहाँ measure होता है? So just mathematical calculation. Okay. We define some observable, no, Hermitian operator. Those things are measurable, like we calculate momentum, energy, these things. So whatever you want to measure, we define some Hermitian operator, real operator. Okay, those things are measured. So thank you very much, guys, for joining this session. Have a great day. And guys, a lot of good courses are going on currently on Unacademy, so you can join this using our referral code Physics Hub or Sahinlive. So these are the batch courses. This course, electromagnetic theory course, is going on. If you want to start freshly this electromagnetic theory, you can join this course. And this accelerate, Unacademy accelerate will be happened on February 28th. So try to attend this. 30 questions will be there, so it will give you a good practice actually. So thank you very much guys, see you in the next class. Bye bye, take care. And today we have a special class at 6:30 p.m. okay, there will be discussing Laplace transform at 6:30 p.m. so try to attend that class. The link has been shared on our Facebook page, you can just check it out. Thank you once again. Bye bye, take care.